Okay, so we all know JavaScript, right? We have a general idea about what JavaScript is. And we can think about JavaScript as being able to run in two different environments, right? We have Node, which is on the server side or on your computer, and we have the browser. And each of these exposes an API, which expands JavaScript's reach. This API has to do with the user interface. And this API has to do with the system. So in Node, you can handle things like files on your computer or directories. You can even go and use HTTP across the internet to a server and download data. All stuff you can't really do on a browser. And this JavaScript core has access to this API, right? So let me show you this API. The browser API has to do with the global scope of window, and you can also think about the DOM as the API, the document object. And you can look into that. You can go on developer.mozilla.org. That's a great website to find information about the browser API. And over here on the Node side, you have the documentation and the table of contents. And here you can find different extensions of the JavaScript core to allow you to access directory names like this, or the file name. You can console log just like you can with the browser API. And you have different scopes with modules, etc. So let's also talk about the different versions of JavaScript. And the different versions are called ECMAScript. ECMAScript. And the first version of ECMAScript was way back in 1997. But what really put JavaScript on the map was the year 2015, with ECMAScript 6. On the street, people call this ES6, but the technical name for this is ECMAScript 2015. This was a huge version for JavaScript. It really took JavaScript from a dinky little thing only in the browser to being a really well-formed, I guess you could say, more fully formed programming language. So let's also talk about who owns ECMAScript. Who is deciding the future of the JavaScript language? And the answer is a group called TC39. I don't know why it's called 39. TC stands for Technical Committee. And the TC39 is a collection of all the major tech companies in the world. Think of the big ones, right? You got Google, Apple, Microsoft, Twitter, Adobe, the big guys, the big guns. They all come together, and you can imagine these guys in a meeting, and they call themselves the Technical Committee. And they all decide what version or what new feature is going to be put into the JavaScript core. And they have a website, and you can actually go and look at their meeting notes. Right here, github.com/tc39/proposals, and they have a 4-stage process. So the stage 3 means that it's really close to being approved. 4 means approved. And you can see that they are running tests on some particular items. And the ones with green check marks are likely to be adopted into stage 4 and put into the JavaScript core library. So things like global this, maybe looking into this might be a good idea because it might become available very soon. Another thing that is absolutely very important to the JavaScript language is JavaScript engines. And here, things operate a little bit differently. In TC39, all the big tech companies are cooperating, right? They're sort of like a committee, and they all vote and they decide on what's important. Here in the engines, they are all developing their own separate JavaScript engine. Google's engine is called V8. This is a very important one. It's the most popular. Mozilla has one called SpiderMonkey. SpiderMonkey. I think that's an actual monkey. Microsoft has one called Chakra. Chakra. And Apple has one called JSC. So these different engines right here, what these are doing is they're taking the JavaScript that you write as a developer, and they're reading it, and which is another word for reading this is called parsing. So the engines parse the text that you wrote, and then they go in and they create eventually bytecode. So it goes from your regular JavaScript over here, which I can read. I know what this does. It makes sense to me. And then the engine takes this code and it turns it into a more machine-friendly code, which I can't read. I really have no idea what this means. But this bytecode is what the computer understands. This is the first level. Notice that the bytecode, there's less bytecode than the machine code. The machine code is one more level past bytecode. And this is like butter to the machine. The machine goes, yeah, I don't even really need to think that hard. You've done most of the calculations for me. There's more text, but the calculations are done, so I don't need to think hard at all. And these engines go through this process. And the different engines go through these stages differently. So the advantage of bytecode is that it's much easier for the engine to get to bytecode versus the amount of calculations it takes to get to machine code. So the engines can pump out bytecode very quickly and get the machine to run the bytecode. But the optimization of the bytecode might take longer for the machine to process. But if the engine takes a little bit more time up front and gets some of the code that's used more frequently to machine code, then the machine is optimized quicker and can run through the code much quicker. But that's there's a give and take there, and there's sort of no given way that's the best way. So these companies down here are deciding on the methods in which to go from bytecode to machine code, and when to just stay at bytecode or when to just go to machine code, and at what levels to do it at. Okay? So up here in the TC39, they're cooperating to change core functionality in JavaScript. But down here in the engines, they're competing to run the JavaScript that they've agreed on the fastest. Okay, so the browser over here, you can imagine that this browser is Chrome, okay? Chrome is built by Google. So naturally, you would assume, and you assume correctly, that Chrome is using the Google engine V8. And that's true. So the JavaScript core needs the engine, right? And when you're running your JavaScript in the browser, if you're using Chrome, you use V8. If you're using Firefox, you're using SpiderMonkey. If you're using I almost said Internet Explorer. If you're using Edge, you're using Chakra. And if you're using Safari, you're using JSC. Same thing with Node. Node, if you download Node, typically what you're using is V8. But there are other versions of Node that use SpiderMonkey and Chakra. I don't think there's a Node version of JSC yet, but for the most part, Node uses V8. Okay, so one of the things that really upped my JavaScript game was realizing that this JavaScript core, when ran in the browser, adapted itself into a whole new feature set, and it was using the API of the browser, right? That was pretty important to my JavaScript development. And the browser has to choose an engine, and the browser has its own API. So like we said before, the browser has the window, it has the document, it has all of these different methods that you can write. These document.body, let's see, forms, head, it just keeps going on. There's a lot of API information that the browser exposes. So when you think that you're doing JavaScript, you're really using the browser API a lot of the time. Same thing with Node. If you're in the Node environment and you are in the server environment in Node, you're using the API of Node, and you might not have access to the browser side. So when you're in Node, you kind of can think about it like this, because Node also needs an engine and the JavaScript core. I hope that made sense. For me, learning this stuff and getting to this level where you really understand who's cooperating with whom, who's competing with whom, how does the engines work, what are they actually doing, and then what environment you're running your JavaScript in, was majorly important to my comfortability with writing programs for the web. Thanks so much. I hope to see you on the next one. Give this video a like if you got this far. I'd really appreciate that. There's going to be way more videos to come, and I hope to see you in those. See ya.